Hello everyone. Today we are going to be discussing the different types of chassis that can be used as part of your robot. To start off, there are many different things to consider when designing a chassis, such as speed, strafing, defensive capability, maneuverability, etc. Knowing the differences and advantages between different types of chassis is vital to understanding exactly what kind of chassis will be best for your team's robot. So, omnidirectional wheels are perhaps the most commonly used wheel type in VEX. They generally come in three sizes: 4 inches, 3.25 inches, and 2.75 inches. Now, omnidirectional wheels have rollers running perpendicular to the actual wheelbase, which allows for better turning due to them negating turning scrub. However, these wheels make it so that your chassis is more susceptible to defense from the side. Mecanum wheels pair with the Mecanum-Drive type only. The details of the performance of this drive and type of wheel are the same as that of the Mecanum-Drive, which I'll talk about later. So the VEX traction wheels are not typically useful for most types of chassis. The fluidity of driving with these wheels are much lower than that of the Omni wheels. They have a higher turning scrub, which is the force that is aimed to the side of the wheels when turning, and overall, turning scrub is bad. So before I talked about the pros and cons of using an omnidirectional wheel. However, there are also differences between the different sizes of omnidirectional wheels. The following information can be proven using formulas and relationships in physics. However, I am not going to be going into the specific formulas used to derive this information. The largest sized 4-inch omnidirectional wheel takes up the most space vertically due to its larger radius. It also provides the least amount of torque, but the greatest distance traveled per rotation out of all of the omnidirectional wheels. This means that if you direct all of the sizes individually to a 200 RPM motor, this one would travel the most distance due to it having the largest radius. As you can visualize, one rotation of the 4-inch omnidirectional wheel will travel further than one rotation of the other two. However, this one would be the most susceptible to defense and worst at pushing things, assuming that they are all using the same ratio, due to the inverse relationship between torque and speed. Now, using the same relationship, we can say that the 3.25-inch omnidirectional wheels is the middle ground for both speed and torque out of all three sizes. It also saves the most space due to how it has a smaller radius and isn't wide like the 2.5-inch omnidirectional wheels. And lastly, the 2.75 omnidirectional wheel provides the most torque but least speed out of all of them. It is also quite wider than the other two, making this wheel extremely space inefficient. So the H-drive. This drive type utilizes the standard tank drive design, with the 4 wheels in each corner, in addition to a strafing wheel in the center of the chassis. This drive utilizes 5 different omni wheels, allowing it to strafe left and right. The position of the center wheel is extremely important. In general, you want the strafing wheel to line up with the center of gravity of the robot so as to not cause problems with tipping or a degraded driving experience. As well, this drive takes up much space in the center of the chassis, making it much harder to build upon than a conventional tank drive. Moving on, the tank drive is the standard 4-wheel design, with 2 sides of wheels each independently controlled, allowing the driver to easily go forward or backward and turn left or right. The wheels are positioned in the 4 corners of the chassis, and this drive allows for the most space in the front, center, and back of the chassis. However, this drive does not allow for strafing, which makes for less maneuverability around the field, though this is perhaps the simplest design to make and can be much more intuitive to drive. Onto the Mecanum-Drive. This drive type utilizes Mecanum wheels in order to have the ability to strafe left and right. The wheels are lined up in the same way that the tank drive design's wheels are, allowing for strafing on a tank drive chassis type. This drive type uses 4 motors, as you can see here. However, the Mecanum wheels are quite large, which ends up taking up a lot of space in the chassis. They also do not always strafe directly to the left and right, and it's really dependent on the center of mass of the robot. Also, Since they're not completely round, as you can see here, they can cause less fluidity in driving and make the overall drive experience more rough and inconsistent. And lastly, we have the X-Drive. This drive type utilizes 4 different omni wheels, 2 pairs of parallel wheels lined up at a 45-degree angle, right here. It is important to note that the distance between the wheels, the closer it is to the center, the easier it is to tip over, especially if it is being pushed from a direction that is not powered. A few issues with this design is that it's difficult to build onto due to its angled corners. You're not going to be able to build and mount lift towers from these angled parts of the chassis. Also, this drive type is unable to drive with the tank control layout, which is the default way to program a chassis. However, it is quite efficient in terms of movement due to its ability to turn quickly as well as its fluid strafing in any direction. I hope that this video taught you a little bit more about the different types of chassis in VEX. Thank you so much for watching.